Welcome to today's webinar. We're happy that you will join us today for building scalable and reliable MQTT clients for enterprise computing. I am Verena and I'm with today's speaker Silvio Giebl, the core developer of the HiveMQ MQTT Client. For the first time, we are also joined by an external guest speaker. We're looking forward to have Clive Jevons. Clive is an independent consultant from Jevons IT, talking about his experience using the HiveMQ MQTT client. We will start in a minute, but before I want to let you know that you can ask questions during the webinar by clicking on the Q&A tab. Questions will be answered either during the sessions or afterwards by Silvio and Clive. Probably we won't have time to answer all of your questions, but therefore all unanswered questions will be answered on the HiveMQ community forum. Additionally, we will also start a quick poll during the Q&A session, and we would be very pleased if you could give feedback on this webinar. Well, I think we're ready now, and I would hand over to you, Silvio.
Okay, thank you, Verena. And thanks everyone for joining the webinar. Our webinar today will be about building scalable and reliable MQTT clients for enterprise computing. So let's start with a quick introduction who we are. I'm a software developer here at HiveMQ. I developed the HiveMQ MQTT client and I'm the maintainer of the library. And I also work for the HiveMQ broker, so I have quite a lot of experience in the MQTT department. So, and we have Clive Jevons here today. Could you please introduce yourself, Clive?
Hi, yes, very pleased to. My name's Clive Jevons, as you can see there on the right, and I've been writing Java software since, if memory serves, 97. So quite a while, but relevant to this part is that I've been doing enterprise software since the early 2000s at least, JE for a lot of that time, and for the last 5 years, I believe, 3, 4, 5 years, thereabouts, we've been using MQTT technologies, mostly in automotive. I will be just relating some of my experiences with MQTT in general, but of course the HiveMQ client in particular. Also, I had a wee small part in the development of the HiveMQ MQTT client. I prepared some of the documentation and some of the examples that you can find on GitHub, and generally provided feedback and was involved in some of the discussions. So back to you, Silvio.
Okay, thank you, Clive. Before we dive in, a quick overview what we will talk about today. The first part will be about what can an MQTT client do, and you will learn how MQTT can really be used for a variety of use cases. Then we will go over to the introduction of the HiveMQ MQTT client, what advantages it brings and why it exists. And then I will hand over to Clive that he can talk about a little bit of his experience about using the HiveMQ MQTT client and using MQTT clients in general for building enterprise solutions. So let's start. First, a quick introduction to MQTT. Probably you know about MQTT already. Just the most important points here. It's a communication protocol. It is a protocol that works with the publish-subscribe pattern. So you publish messages and the clients that are interested in these messages subscribe to these messages and so get these messages. What's really special about MQTT is it's a really good standard. So you don't have to worry about in 10 years that you cannot use it. So the interoperability is a key benefit of MQTT. Another benefit is that the sender and receiver, so all MQTT clients, are decoupled from each other. This makes the system in general more robust and scalable, because if one client is down for some reason, it does affect the whole system. Instead of known protocols like HTTP, where you have to retry yourself, you have to build a logic that detects if something failed and then actively retry. MQTT gives you quality of service levels. So this makes communication over unreliable networks a little bit easier for you. So that's another benefit of MQTT. And all of these features are really provided by a flexible and lightweight protocol. You don't have to set up topics. You don't have to worry about that your data has to be in a certain format. So it is really adaptive to your use case, and we will see that later also. Short about the use cases. It's known for the IoT protocol. It's often called the standard IoT protocol. And yeah, therefore IoT, industrial IoT, industry 4.0, connected cars, what Clive will tell us about later. And in general, MQTT can be used for everything that needs to connect a lot of devices. And by a lot, we mean not a couple of thousand. We talk about scales of million clients. Yeah. And the really special part about MQTT in 2019 is we now have MQTT 5. And MQTT 5 is the next version of the protocol. We had a webinar about MQTT 5 already, so I highly recommend that you watch this on YouTube. There are really the key benefits why MQTT 5 is an improvement over the last version, and why MQTT 5 enables even better use cases. So quick history of MQTT. It started in actually before the 2000s, in 1999. Officially released as a standard, it was in 2014, and now in 2019 we have the new version of MQTT 5 as an official standard, and we highly recommend using this for new projects. And we will see the benefits when we talk about the HiveMQ MQTT client later. Okay, what is an MQTT client? That's actually a good question, because we often think that MQTT clients are just sensors or small devices, but an MQTT client can really be a lot of things, and it is actually used for a variety of systems. So we will talk about enterprise use cases. Enterprise use cases often have a lot of different systems involved. You have the embedded systems like in cars, like small sensors, like control units, but you also have backend systems that integrate a lot of other systems and act as the central data hub. But we also have something different. We have mobile and desktop clients. So all these different systems, what they all have in common is they want to communicate in a reliable way. And what they also have in common, they are not just one, they are not just 100, there are probably thousands or even millions of these clients. So MQTT is actually a solution for all these different kinds of systems to connect them and to have a reliable communication between them. Okay. Let's talk a little bit of what are the requirements for embedded, because embedded backend, there are differences in their requirements. Embedded devices often have lower computing power. They have often unreliable networks with low bandwidth and high latency. And MQTT really solves these problems by providing really lightweight clients. So the heavy things move to the broker, the MQTT broker, and the clients are really lightweight, and so they can run on these embedded devices. Also, MQTT ensures that the network overhead is minimal. So we will see this later with the HiveMQ MQTT client, that the clients are really lightweight and don't have a lot of overhead. And we have quality of service guarantees. So you can specify if you have a really important message that has to arrive at your broker and at your subscribers, so that when you have an embedded device like a control unit in a car and the car moves and your network is unstable, you get the guarantee that the message gets delivered. So you can avoid message loss. Mobile applications have different requirements. The most requirement they have is that they need to be platform independent. Nowadays, we have a lot of different platforms in the PC market, in the tablet market, in the smartphone market. We have responsiveness requirements. So users really expect to have millisecond latencies. They want to have, if they subscribe to some messages, they want to update as quickly as possible. And we also have unstable networks because of cellular networks that are not always the most stable. And here MQTT also has these requirements covered. So it's really a standard. It is interoperable, so no platform dependency. It is responsive because it is a push-based system. So if you deliver messages to the clients, they get it immediately, so to say. And yeah, the quality of service guarantees ensure that if the network is unstable, that the messages get delivered. Backends have different requirements. Mobile and embedded were kind of similar, but backends usually are used, a few amount of clients are used to handle a lot of traffic. So that's different to embedded, where we have millions of clients that only send data every minute or so. Backends often have a huge amount of data flowing through them, and that's a different requirement. But we will see that MQTT also can provide a solution for this. And backend systems often need to scale. So you start with say 1,000 of clients, and then your business case gets to a millions of clients, and then you need scalability and reliability. And these requirements are also covered by MQTT, especially with the new MQTT version 5. We got a lot of features that ensure this scalability, ensure that we have back pressure, so we have stable and reliable systems. And we have shared subscriptions. Another feature that's standardized by the MQTT 5 specification. And shared subscriptions are used to group different MQTT clients together, so they act as a virtual MQTT client, and the broker then load balances the messages on this group. So for example, if you have 1,000 clients that publish a message every second, you get 1,000 messages per second, and you have 10 backend servers. Every of these backend services will get roughly 100 messages per second. So you have really this load balancing built into MQTT and in a flexible way. So you can remove clients from the group, you can join clients to the group. And so you have really flexible scaling. Okay, shared subscriptions, I talked about this. Now let's take a closer look to the HiveMQ MQTT client and how actually an MQTT client can solve these problems and can solve these requirements. A short introduction about the MQTT client from HiveMQ. It is a Java library to connect MQTT clients. It supports all features of the MQTT 3 and MQTT 5 specification, including all the optional features. So it is really a 100% implementation of the MQTT specification. It is open source, so everybody can use it for free. And what makes it special, it has different API flavors. So you probably know the blocking and the asynchronous API styles, but the MQTT client also added a reactive API. I will talk about this soon, why we need reactive or when you need reactive. It has back pressure built in, so if you use it for enterprise systems, you often need the stability and reliability of the services, and that the services don't get overwhelmed by too many messages. I will talk about back pressure later too. And I will also talk about the resource efficiency of the HiveMQ MQTT client and how the resource efficiency benefits all the use cases from embedded over mobile to backend systems. Okay, a quick overview of the MQTT features. The MQTT 3 and MQTT 5 specification have most features in common. So you get all the call to service levels, you get retained messages, you get the last will and testament, you get sessions, you get queued messages, all that kind of stuff. And MQTT 5 added valuable features on top. You can now specify a session expiry. So previously you could say, I want a session. Now you can say, I want that my session lasts at least 30 minutes. So if you have a connection loss, you can reconnect and no messages will be lost. Message expiry is also a new feature. So if you want to expire messages that are not as important, you can say this message is, if it isn't delivered in 2 minutes, then please expire the message, because we have new messages that are more important. A big feature of the MQTT 5 specification is flow control. It enables back pressure handling, and that's a key part of the back pressure handling implementation of the HiveMQ MQTT client. Shared subscriptions, as I already mentioned, were standardized in the MQTT 5 specification, but they also were supported by brokers like HiveMQ with MQTT 3 already. So it is actually nice to see that this is now standard. And we got a lot of features like more metadata for the published messages, user properties. reason strings for better debugging. We got a standardized mechanism to do request response. Although MQTT is a publish subscribe pattern, we can now make request response pattern style communication over MQTT. And we get a lot of internal features like topic analysis. They reduce the bandwidth that is required on the network. Subscription identifiers, the same. And we get a new enhanced auth mechanism that makes authentication and authorization more flexible. And security and authentication is a big part of IoT. So it's a nice addition to the MQTT specification. So now the MQTT features, I already said that the HiveMQ MQTT client implements all these features. I'm a little bit confused. That's the wrong slide. That's the slide I was looking for. We have a lot of features on top of MQTT, like encryption of the transport via TLS. We have WebSocket support and also secure WebSocket support. Automatic reconnect, that's a really important part. You really want your MQTT client to reconnect if there is a communication failure, like the network has gone down for a minute, or you moved to another region and the network is unstable. So automatic reconnect and is really an important part for MQTT clients. And I will show you an example later. Offline message buffering. So if the client is offline, the messages are not lost. We have an automatic thread management. This means you don't have to worry about it. But if you want to worry about it because you want really to specify which threads are used, you can really configure this. And all operations of the MQTT client are thread safe. So there is you don't have to reason about which operations are safe to be used. So every operation is really thread safe. We have pluggable authentication support so that you can write your own authentication mechanism and authenticate your clients. And we have a lot of features. The most important one is back pressure handling, because it really is an important part for enterprise systems, that they are stable and resilient, and back pressure really helps there. So it is open source, Apache 2 license. You can really use it for free. It is maintained by HiveMQ, but we are really interested in your feedback. Really welcome if you want to contribute. So just take a look at the GitHub project and post your feedback and maybe also contribute. Why is it open source? Because MQTT is their standard IoT protocol nowadays, and everybody should be able to use MQTT, and this in a reliable way. I have two use cases that we have from HiveMQ, from the HiveMQ MQTT client, and these use cases really show how MQTT clients can be used for different use cases. So the MQTT CLI uses the HiveMQ MQTT client, and we have an internal device simulator tool that is able to simulate millions of MQTT clients with only a few machines. So this is really important for us at HiveMQ, because we want to load test the MQTT broker, and we needed a solution that does not require a lot of hardware to simulate a lot of MQTT clients. And what's really important is that you can use this library in a flexible way. So you don't have to choose an architecture up front. You can start prototyping with an easy blocking API. So it is often simpler to start with just easy steps, small steps, and develop further. So you don't have to think about all the architectural changes you have to make in the future. So the HiveMQ MQTT clients really allows evolution of applications, starting out with blocking API or an asynchronous API, and move then to reactive APIs. And you don't have to if your use case doesn't require it. But I will show you that for enterprise computing, the reactive way of programming really makes a difference and really helps building resilient and robust applications. Okay, I talked about that the HiveMQ MQTT client is a lightweight MQTT client. So in general, MQTT clients are lightweight, but what does this mean? The communication part, so the MQTT part, should not be the major part of the application. Your application wants to move data from the application to the broker, from the broker to other enterprise systems. And the communication is just a means for you to transport the data, but the really important things are the data you transport. So the overhead should be really low from the MQTT client. And to have a number for this, the HiveMQ MQTT client needs around 5 kilobyte of memory per instance. So this is not a lot, but you can really rely on the robust and delivery guarantees of MQTT, although you have just so a lightweight client instance. You can use many clients, as I already said. We use the client library to simulate a lot of millions of MQTT clients with a few machines. But you can also use one MQTT client and use it by different threads, because you can really use it in a thread-safe way. Yes, I already said this. I will move a little bit faster here. I talked about how embedded mobile and backend use cases can be solved by MQTT. And now I will talk about how the HiveMQ MQTT client can be used in these 3 use cases. The resource efficiency of the library helps in all cases. So embedded, you have restrictions from the hardware and from the network. And backends typically have a higher throughput of messages, and resource efficiency there also helps to improve the throughput. And for the backends, we have shared subscriptions. So like most MQTT clients, you can use shared subscriptions with the HiveMQ MQTT client as well. And on top of that, the HiveMQ MQTT client allows to handle back pressure. This means if you have a shared subscription group of 10 clients, so these are your microservices in the backend, and you want to distribute the load on these systems, back pressure helps that a single of these services is not overwhelmed with all the messages, so that all messages are better distributed to your services. And the HiveMQ MQTT client can run on the backend, we saw, and it can also run on mobile. We have support for Android, and for Android APIs 19 and up. So this is actually quite a lot of market share, almost 100%. And the reactive API helps on Android. because a lot of libraries on Android are written with reactive libraries, and because of the responsiveness of reactive programming, it is loved by Android programmers. But the reactive API can also help in the backend to ensure the resilience and improve the overall robustness. Okay. I talked about reactive a lot today. Why would you even need this? The reactive manifesto states some features of a reactive system. It is responsive, resilient, elastic, and message-driven. And MQTT, it's a message-driven protocol. It is built for resilient systems with the quality of service guarantees you get. And it is a responsive system. It is a push-based system. And all these features of that the reactive manifesto states are really a perfect fit for MQTT. And reactive is a solution that is able to scale better for applications. So it is really a good use case for bringing MQTT to the backend. The HiveMQ MQTT client is reactive. It is in its inner architecture, it is reactive, but it also exposes a reactive API. And this reactive API can be used on mobile, on Android, as well as in backends. And a key part of MQTT is that it is interoperable with all clients. And also the reactive library we are using in the HiveMQ MQTT client follows a standard. It's the reactive streams standard. And so you have also the interoperability on the MQTT layer, and you have the interoperability of the library layer. Reactive, the downside of reactive is it are new concepts. It is, you have to think differently. It is not the normal control flow oriented way of programming. It is more data flow oriented. So it's really about the data. That's why it's a so good fit for MQTT and IoT, because the data is that what is really meaningful, and reactive really puts the emphasis on the data. But the good news is, although you have to learn new concepts, you don't have to immediately. You can start using the HiveMQ MQTT client with the asynchronous API. And if you require the reactive API, just move to the reactive API later. And you can use the asynchronous API and the reactive API simultaneously. So there is really, you can evolve your applications and are locked into an architecture. Good. I also talked about back pressure. I already said that it's a mechanism to adapt the message rates. If they are too high, you want to tell the systems, don't send me too many messages. What can happen if an application is overwhelmed by too many messages? The application might crash. That's the worst thing that could happen. It also could happen that important messages get dropped and nobody notices it because it's one client that gets overwhelmed and the messages are simply lost. And if the messages are dropped, you have done a lot of unnecessary work because you have to send the messages over the internet, and you have to pre-process the messages, and then you realize, oh, the rate is too high, I will drop the message. So back pressure really helps to adapt the message rates so that single MQTT clients are not overwhelmed by too many messages. And what you do if a single MQTT client is not enough to handle the message throughput, you just scale out your MQTT services via, for example, share subscriptions. Yes. And that's why share subscriptions are really a key feature of MQTT for enterprise computing and for the backend. Okay, and MQTT 5 has, besides standardizing the shared subscription feature, it also has the flow control feature that really helps the implementation of the HiveMQ MQTT client to implement back pressure and to tell the broker, I cannot process more messages. Please send me messages in a lower rate. So I have code examples, but I think we are really, we have a lot of time spent on the previous slides. I guess I will hand over to Clive now, and we will take a look at the code examples if we have time afterwards. Is this okay for you, Clive?
Works for me.
So I will just
jump ahead.
Jump ahead. Okay.
There we go. Right. Well, my part's going to be considerably shorter. What I wanted to do was highlight 3 different use cases that we've had in the real world recently using the HiveMQ client. Really, all the features that Silvio has mentioned up until now have been things we've had to use in these scenarios. So, for example, if we look at the first one, mirroring fleet data between clusters. Now, what do I mean with that? And this, forgive me, I can't be too specific about customers or the nitty-gritty of the business details. So I've got to describe some of the aspects in an abstract way. But I'm allowed to say cars are involved. And obviously cars are out in the real world. And we all know, well, certainly in Germany, the mobile networks are somewhat patchy, shall we say. So they're not very reliable. So we've got that. Also cars, the onboard computing is a lot less than we are used to having sitting on a desktop in the form of our notebooks. So they need the low overhead part. And it does have to be reliable because there are certain messages that the cars want to send to us. And we really want to get those messages. So the reliability part is done with that. But I'm not going to go into too much detail about the embedded side, the car side of this. Is what I'm going to describe more is what's happening in the back end. So the systems running in the cloud that are consuming and processing all of this data. And one of the first, or in fact, the first use case, if I remember correctly, that we used the HiveMQ client specifically for was taking data from one fleet and mirroring it across to another application cluster so that we can use it for testing purposes instead of writing some kind of artificial data generator. We just thought, well, we'll use the data that's there from the cars driving around. And the nice thing was really that I wrote this in using Micronaut as a microservice. The whole thing, the whole backend's all microservices. So I grabbed Micronaut and I threw the HiveMQ client in there and had it up and running real quick, which really speaks to the attention that was paid to crafting the API. Now, because I'm a glutton for punishment, I decided to then widen this out to use the reactive API, which I'm not myself too familiar with, but I got into it and was able to get that up and running fairly quickly too. Deploying it out was running in 3 nodes. So we got the shared subscription aspect running there. And in the cloud, when you look at the monitoring data of the resources being used, the various instances are barely breaking a sweat. and they're processing, I think I checked last, it was about between 12 and 15,000 messages per minute. So the throughput was there, and they're not even breaking a sweat, so they could handle a lot more. And also resilient, we've had it now and again when a node dropped out or stopped receiving messages for whatever reasons on the network for a while. And the other two took up the slack and kept pumping the data. So that works really well. Yeah, so that's the first one. That was Micronaut with the HiveMQ client, just straight up in a bean using that. Worked very well. The second use case here is we integrated, well, Joiner is another open source project, which you can also find on GitHub. And in the case of that with Joiner, I won't be telling you a secret when I tell you it's developed by BMW, because you can see that when you go to GitHub. And it's the communication middleware for handling various aspects between the backends and the cars, or even if the cars are communicating amongst themselves. And we had, anyone that's done any MQTT work in Java before the existence of HiveMQ knows that pretty much there's just the one. It was the Eclipse Paho client that we were using before. Having a lot of trouble with performance, resource usage, and also dropouts wasn't the most reliable thing. And we ended up spending a lot of time, not just in there, in most of the other projects that we've used MQTT in as well, of having to write a whole load of code around the Paho client to get it to be stable with retry strategies and manually built ping keep alive mechanisms to see if the communication is really still happening or if Paho is just lying to us when it says it's connected. And pleased to say, so far, touch wood, certainly after integrating HiveMQ, there's a lot less code involved, because the HiveMQ client just did everything a lot better out of the box, which was very nice. Because this was integrated into a library with this, we decided certainly to start off with the reactive API straight away. And I should also mention that all of these are using the MQTT 3 specification or version. We haven't upgraded to 5 yet, but we certainly want to, because, for example, the back pressure mechanism is going to be very, very interesting in this middleware scenario, amongst others. Also, the request response mechanism should be interesting, because that's something the middleware abstracts and implements, but it implements it via sort of manually built request and response topics. The third one, a very recent one, I have to be very vague here, but it's a plant which is producing things, and but during the processing, there's certain touch points within the process where sensors are sending data. So a fairly classic use case for MQTT. This is on the backend side. The consumer of this data is a JEE application. And one thing that I was very, very happy about is something that also appeared briefly on a slide before, that you can get involved in how the threading mechanism is fed, because of course JEE reacts or can react a little bit sensitive to people starting their own threads, but with JEE concurrency utils, of course, you now have things like managed thread factories and managed executor services. And so during setup, nice API for setting up the client in a sort of builder pattern. and you can just have a bean that sets your client up, startup singleton, for example, which injects a resource managed executor service, and during the build process gives that to HiveMQ, and everything works out of the box, no problems there whatsoever. With all of the three I've listed there, certainly we are also using the shared subscription model, which, as Silvio said, the nice thing is that HiveMQ Client supports that for MQTT 3 as well. You don't have to have MQTT 5. Of course, you have to then have a MQTT 3 broker which supports it in the background. And maybe unsurprisingly, in most of those cases, that's also a HiveMQ. Not all of them, but in most of them. One thing to be aware of with the shared subscriptions, although I don't want to go into too much of the nitty-gritty details, is if you are needing a system which has needs a higher QoS and reliability for when the clients reattach. Of course, the clients then need to reconnect to the server with the same client ID so that their session can be found, so that the broker knows to forward messages to that client which it has missed. And most certainly the first use case here, for example, with the mirroring, it's just a really simple app that's stateless. So that just has random client IDs when it connects. And if one is out, we don't care that the session's gone. With other use cases, that was more important. And then if you're, of course, running in a cloud setup where you may have some scaling involved, and that it gets a little bit tricky with ensuring that each node has the correct client ID when it's starting up. I think, and yeah, another thing I wanted to mention also regarding the APIs as a last point, very much appreciated that, as I'd mentioned before. And for example, the blocking API in a Groovy script is great for if you just want to test something. You just grab the HiveMQ MQTT client into there, and you can use the blocking API for, because a script is generally not going to be something that needs to be asynchronous. And in the, for example, JE world, if you're just integrating a first time, the async API is a great place to start. And then, as in use case 2 here, where we're integrating it into a framework, a middleware, or if, for example, your project has some kind of technical base project which provides certain utilities for the applications, there the reactive API is a really great way to go. So yeah, I think that's pretty much all I wanted to say. So Silvio, I'll hand it back to you.
Thank you, Clive, for your experiences with the HiveMQ client and MQTT clients in general using in enterprise applications. So I think we should start the Q&A session now. There.
I think there's currently one open question here.
Just a minute until we see the question. We don't see the question yet, but we have a notification that there is a question.
Silvio, it's Ian. I can read the question, so I'll read it to you. Can I connect to the Azure data lake with HiveMQ?
What, Ian? I didn't understand you. What?
The question is, can I connect to the Azure, the Microsoft Azure data lake on HiveMQ? So I think what they're asking is, can you take messages from HiveMQ and put them into the Azure data lake?
As far as I know, the Azure API is not a 100% MQTT implementation, but I guess you can connect via MQTT to Azure. So I think, yes, it's possible. I don't really know the APIs of Azure.
But I think what I would suggest is someone could easily write an extension using the HiveMQ extension SDK that would kind of use the Azure APIs to convert an MQTT message and route it into the Azure data lake.
Okay.
Are there other questions? It doesn't look like there's any other questions, so I would suggest you could wrap it up.
Or if we have time, I don't know, Silvio,
Questions?
if you wanted to share.
We're ready. So thank you, Silvio, and also a special thanks to Clive for your presentation. Thank you for joining us today. We hope you enjoyed this session. If you want to watch it again, the video will be uploaded on our YouTube channel. So I will also provide you the link in the chat in a minute, so you won't miss it. And so you also have stated that you can update, you will get updates to the webinars on our upcoming newsletter. Make sure to subscribe so you will never miss any upcoming webinar. And well, as there were no questions, there will also not be questions answered on the community forum, but if you have a question, feel free to reach out to us.